discuss about the thermodynamics involved in the working of galvanic cell. The basic principle in working of the galvanic cells is the conversion of free energy change involved in a simultaneous redox reaction to work. So, the basic principle is the free energy change involved in a simultaneous redox reaction converting to electrical work done by the cell, galvanic cell. So, free energy change in the reaction is delta G, and work done by the cell is charge into potential, that is minus NF, that is charge into potential, that is E cell. Therefore, delta G is equal to minus NF E cell. This is the basic relation. Of course, from this only the Nernst equation also we have derived it. So, this delta G is equal to minus NF E cell, and also that delta G is equal to minus 2.303 RT log Q. So, from this also what we have derived is E cell is equal to E naught cell plus 0.059 by n log Q, and also delta G is equal to delta H minus T delta S, where delta H is the change in enthalpy, of the reaction. Delta S is change in entropy of the reaction. T is the temperature at which the reaction is carried out. These are the various relations. So, also in the thermodynamics we have dou delta G by dou T is equal to delta S. Dou delta G by dou T is equal to delta S, that is change in entropy. So, using all this we can get a relation for the EMF versus other thermodynamical properties. So, because delta G is equal to delta H minus T delta S and E is equal to minus NF, delta G is equal to minus NF E cell. So, from this what also we can write is that the as E delta G is equal to minus NF E. Therefore, from this what we can write instead of this, now if you substitute this, dou minus NF E by dou T is equal to delta S. Okay. So, from this, so first we are taking delta G is equal to minus NF E cell, and in equilibrium and thermodynamics also we said delta G is equal to minus 2.303 RT log Q, where Q is the reaction coefficient, and from which the Nernst equation, of course, E cell is equal to E naught plus 0.059 by n log Q is derived, and In thermodynamics, also we say delta G is equal to delta H minus T delta S, where delta H is change in enthalpy, delta S is change in entropy, and T is the temperature at which the reaction is carried out. Now, from this relation delta G is equal to delta H minus T delta S, also we say that dou delta G by dou T is equal to delta S total. This is delta S system, this is delta S total, or I will put it as delta S total. Delta S total means delta S system plus delta S surroundings. Now, from this delta G is equal to, because minus NFE is also in the place of this delta G, substitute this NFE, then you will get this. Now, this is a very important relation from which you will get another parameter, that is temperature coefficient. What is the temperature coefficient? Just now we write it down as dou minus NFE by dou T is equal to delta S. From this, what we can write is that minus NF dou E by dou T is equal to delta S. Here N and F are constants, the variable is only the EMF. So, now this dou E by dou T is what you call temperature coefficient of the galvanic cell. Temperature coefficient of galvanic cell. Therefore, now this temperature coefficient dou E by dou T is equal to, this is minus delta S. So, this is delta S by NF. Dou E by dou T is equal to delta S by NF, because this now dou E by dou T is the temperature coefficient. So, this gives us the variation in the EMF of a galvanic cell with temperature is dependent on the entropy change of the total entropy change involved in the working of galvanic cell. This is the total entropy change involved in the working of a galvanic cell. The total entropy change involved in the working of a galvanic cell divided by the net charge transfer taking place in the galvanic cell, that will give you the temperature coefficient. Means with what rise in temperature, I mean with certain change in temperature, how the EMF changes, this relation. Now, this is the, from which this is the very important thermodynamical relation with respect to the galvanic cell, as it gives us variation in EMF with variation in temperature, and which we can say that it is dependent on the, what do you call, the total entropy change of the process, right. Now, from this, here also what we can write is delta S in fact is equal to, again delta G is equal to delta H minus T delta S. So, this again you can put it in different ways. Delta, this is in fact is equal to delta H by T. So, that is again delta H by T and F, all that various relations we can be keep writing. So, this gives us what are all the thermodynamical relations that we can use in the working of galvanic cell. Next, what we will see is something called Latimer diagrams.